In this video, we'll take a look at z-scores and raw scores, or solving for x given z, mu, and sigma, the standard deviation. Now first, let's start by briefly reviewing z-scores. Here's the z-score formula, and you can see here in this formula that z is equal to x minus mu over sigma, where x is a raw score, or a value on a variable x, mu is the population mean, and sigma is the population standard deviation. And z indicates the number of standard deviations a score or value is from the mean. For example, a z of 1 indicates that the x value is 1 standard deviation above the mean. Now we can take the z-score formula, and through algebraic manipulation, it can be re-expressed to solve for x as follows. X equals mu plus z times sigma. Now once again, this is just the z-score formula where we've changed it, where we've just isolated x. And this is often provided in textbooks. So we use this formula when we don't want to find a z, but instead when we want to find an x. Okay, to solve for x, notice that we need three values: the mean, the z-score, and sigma, the standard deviation. So let's go ahead and take a look at a few examples. Okay, in our first example, we have a z-score of 2, a mean of 50, and a standard deviation of 10, and we want to solve for x. So using that formula, solving for x, we see that the mean is 50, the z-score is 2, and the standard deviation is 10. So multiplying that out, we see x is equal to 50 plus 20, or x is equal to 70. Okay, so that's it for that problem, but it is helpful if you can process the following. So let's take a look at this. And this is just trying to get a conceptual understanding of what's going on, but it can be quite helpful. So if the standard deviation is 10, as we see here, and a score is 2 standard deviations above the mean, that is, the z is equal to 2, which we saw right here, then the score is 2 times 10 points, or 20 points above the mean of 50. That is, it's equal to 70. So in other words, what this is saying is if we know our standard deviation is 10, and our z indicates the number of standard deviations a value is from the mean, so we're 2 standard deviations from the mean, each standard deviation is worth 10 points, then we're 2 of 10 points, or 20 points, above the mean. 20 points above the mean of 50 gives us the 70. Looking at another example, here we have a z of negative 1, a mean of 50, and a standard deviation of 10. And we want to solve for x. Now, it is important to note, if you see a negative z, that means that the x value is going to have to be below the mean, because negative z values are below or to the left of the mean. So using our formula once again, we have a mean of 50, z is negative 1, and the standard deviation is 10. So that's 50 minus 10, or 40. So the answer is x equals 40. And looking at the conceptual understanding for this problem as well, if the standard deviation is 10, as we saw here, and a score is 1 standard deviation below the mean, or in other words, z is negative 1, which we saw here, then the score is 1 of 10 points, or just 10 points below the mean of 50. That is, it should be equal to 40. So because our z-score indicates the number of standard deviations a value is from the mean, we see that this value is 1 standard deviation below the mean. So it's one of these, or just 10 points below the mean of 50, which gives us an x value of 40. Okay, in our last example here, we have a z of 1.2, a mean of 100, and a standard deviation of 15. Using our formula once again, our mean is 100, and we have a z of 1.2, and then once again standard deviation of 15. So that gives us 100 plus 18, or an x of 118. And we can see here if the standard deviation is 15, and a score is 1.2 standard deviations above the mean, or in other words, z is 1.2, then the score is 1.2 times 15 points, or 18 points above the mean of 100. That is, the score should be 118. Okay, here we have a number of different problems you can work on to get the necessary practice to make sure that you know how to get the x. And as a hint here, once again, every negative z should get you an x below this new mean, and every positive z should get you an x above the new mean. And on the next slide are the answers for these problems. Okay, so these are the answers for the problems on the previous slide. This concludes the video on solving for x given z, mu, and sigma. Thanks for watching.